Now we're in timing land. Duration is the amount of time from the onset to the endpoint of a behavior. So duration measurement starts with one non-negotiable. You have to know what counts as the start and the end of the behavior so you can time from onset to offset. There are multiple ways to use duration depending on what you need. One, total duration per session. That's the total amount of time a person engages in the behavior during an observation period, found by summing the durations of all occurrences. Two, task completion time. That's the time required to complete a defined task, like time to complete a math worksheet or an academic task. Three, duration per occurrence. That's how long the behavior lasts each time it occurs. And you can calculate it by dividing total duration by count of occurrences. Here's why that matters. Duration per occurrence is often preferable to total duration per session because it tells you whether changes in total duration were due to the behavior happening more often or lasting longer each time. Okay, how do you actually implement timing? Timing devices and procedures are used to measure duration. In applied settings, you're more likely to use non automated instruments, while researchers might use semi automated computer driven systems. The most precise non automated instrument for timing duration in applied settings is a digital stopwatch. Wristwatches or wall clocks can be used, but they're less precise. Here's the procedure for recording total duration per session with a stopwatch. Start the stopwatch when the behavior begins, stop it when the behavior ends. Without resetting the stopwatch, start it again at each onset and stop it at the next offset. So it accumulates total duration across occurrences. Then at the end of the observation period, record the accumulated duration on your data sheet. Now, exam language. If the question says how long did the behavior last or total time engaged, you're in duration. If it says time to finish the task, you're in task completion time. If it says average length of each episode, you're in duration per occurrence. Total duration divided by count. Also, notice the method to dimension match. When the target behavior occurs over extended time periods, event recording won't give accurate measures, and timing is a better match. Latency is one of those words that sounds scary until you anchor it to the definition. Response latency is the elapsed time between the onset of a stimulus and the initiation of a subsequent response. And here's why it's useful. Response latency is a measure of temporal locus. It identifies when a behavior occurs with respect to another event, like an antecedent stimulus. So if you're measuring latency, your measurement question is how long after the stimulus happens does the response start? Now, implementation. This is where you win or lose points. Timing procedures for latency are similar to timing duration, but for latency, you need precise detection and recording of the time that elapses from the onset of the antecedent stimulus event to the onset of the target behavior. So your BT steps look like this. Identify what counts as the onset of the stimulus event you're timing from. Identify what counts as the onset of the target behavior the first moment it starts. Then record the time elapsed between those 2 points, stimulus onset to the behavior onset. And because this is timing, the same tool guidance applies. Use timing devices for latency, including digital stopwatches and stopwatch apps. Now, what do you do with latency data? A common way is to summarize latencies within the session using mean, median, and range because you often have multiple latency measurements per session. Exam callouts. Listen for time from instruction or stimulus to response start equals latency, and onset of antecedent stimulus event to onset of target behavior equals the timing anchor for measuring latency. Let's finish strong with interresponse time or IRT. Interresponse time IRT is the amount of time that elapses between two consecutive instances of a response class. It's a measure of temporal locus, but instead of relating the behavior to a stimulus, it's reference to the previous response. Here's the timing anchor. IRT is the elapsed time between the termination of one response and the initiation of the next response. Now, implementation. The procedures for timing IRT are similar to timing duration. Measuring IRT requires recording the precise time that elapses from the termination of each occurrence of the target behavior to the next onset of the next response. So your BT steps are define the response so you can detect its termination, its endpoint, detect the initiation, the start of the next response, then record the time between those. Termination of response 1 to initiation of response 2. Now, why do we care? IRT is functionally related to rate. You can infer rate from IRT data and vice versa. So if rate is about how many per unit time, IRT is how much time between hits. Two sides of the same timing story. There's also a direct applied connection. The IRT distribution can be used to implement and evaluate differential reinforcement of low rates, DRL, and differential reinforcement of high rates, DRH. And if the goal is to increase rate, a DRH schedule could reinforce short IRTs, and the IRT distribution can give a sensitive measure of behavior change. For reporting, IRTs are typically summarized across responses in a session by reporting the mean, median, and the range. Exam callouts. If you see time between responses or pause between instances, think IRT. If you see termination of one response to initiation of the next, that's the exact IRT timing anchor. And if you see DRL or DRH paired with timing between responses, think IRT distribution. And that's it. And that's A1. You can implement continuous measurement for occurrence, count and rate and frequency language, duration, latency, and IRT using event recording and timing procedures exactly the way they lay. Continuous measurement detects all instances of the target behavior during the observation period, and it's preferred whenever possible. Count and rate, frequency, language, duration, latency, and IRT map onto behavior's repeatability, temporal extent, and temporal locus, and you implement them using event recording or timing procedures that match the dimension you need.